Hello, welcome back to Reliquia Park. Hold on. Right, Reliquia Park. So last episode we finished the abyss for the, what are they called? Totems? Yeah, which are the so-called chess pieces. Next up we're going to be doing the abyss for the spires, which are also not that easy of a mechanic actually. They are a lot simpler to grasp but a lot harder to solve, which I suppose makes some sense. Alright, so let's see if I can find the secret code for it. The secret for Spire is 9S9 bolt 0. Alright, let's key that in. 9S9 bolt is that. And here you go. This should lead to the Spire secret. Consuming this place was futile. It remains as a warning. Completion of these 5 trials will reward you with the secret fragment. Abyss Travels, yeah, okay, so I don't know if I'm going to read this warning every single time, but yeah, these puzzles do get quite challenging, as you've seen. It took us 50 minutes for 5 levels in the previous, in the secret for totems. Anyway, Abyss levels can be quite unfriendly, unbalanced, and experimental. They're also completely optional and not required to complete the game. Only attempt if that interests you, and do not be afraid to move on when you get stuck. So yeah, let's begin. The rules of Spire are... well, okay, we start off pretty challenging already. It looks like everything is off in this one. It looks like, well, the rules are that you need to form these things. So these lines of 4, and these lines of 4 can be any straight line you can form. So a line of 4 can be made of 4 lines in a knight pattern, 4 lines in a diagonal line, 4 lines in a straight line horizontally or vertically. Well, they're all straight, but 4 lines orthogonally, horizontally or vertically. The middle square only lights up when you've used all the spires. I believe that is actually true. I keep confusing myself on whether that is the case or not, or whether this one means a third line, because the more lines you make, the more of the corner pieces line up. But I know this is not true now, because when you form a third line here, the third line doesn't actually... oh. Wait, what? So it is... okay, so that's really weird. So now I'm really confused. Anyway, now we have 5 empty segments, so it essentially makes sense that we need to form 5 empty lines. We do have a setup solution for how 10 objects can form 5 lines. And it is sort of a, like, the letter A, I believe. If you do the math, for 5 lines to actually be made of 10 spires, you have to have intersections where the same lines use the same... there were different lines use the same spires. And because 5 lines should in theory have 20 total points, using only 10 spires in... 5... wait... 5 lines doesn't even feel possible. Right? Because 5 lines should use 20 points. And 20 points with intersections resulting in only 10 spires implies 10 intersections. Which just doesn't make sense. Although points can be intersections for more than one line. So for example, you can have a point that is the intersection of like 3 lines. So you can have a point that is made of the knight line, a vertical line, a horizontal line, and so on. So you could have something that looks like this. That's another line that forms there. And then you can have a third one that looks like, you know, another knight line, basically. But I'm not sure, you know, how easy it is for this to sort of become 5 lines here, so... yeah. This is 4 lines, and that makes sense because you have 1 line horizontally here, 1 vertical line here, 1 diagonal line here, and 1 diagonal line here. Have I done a 5 before? I feel like I have in like one of the older puzzles, like the last puzzle in Spire. Don't remember if I actually... I remember the puzzle solution was not in fact... the puzzle solution was not in fact like symmetrical at all. But it did involve like a diagonal line like this plus a horizontal line, horizontal line, right? Honestly, I'm not sure. But there are a few ways you could make this work out. You could have a diagonal line like this. So there are options, right? I'm not sure how easy it is for the options to actually converge though. Because the idea of the idea of just I don't know. Sorry, I forgot what the I forgot what the old solution was. The previous solution we had. Oh well. Oh, so this, yeah. Sorry. How many intersections does this have? This is 4 lines, so there should be 6 intersections, right? 1, 2, 3, 4. Wait. This is a line. This is a line. This is a line. This thing over here is the intersection of 3. Yeah. Intersection of 2. 1, 2, 3, 4, 5. Wait. 1, 2, 3, 4, 5, 6. It is the intersection of 6, I think. At least. Have I solved this kind of puzzle before? I'm pretty sure I have. I'm pretty sure I have. But I don't remember the solution. I want to see if I can secretly go look at an old solve of mine. That would have been in, I think, here. I believe. Okay. Oh no. Yep. Okay. 2, 4, 6, 8, 10. Yeah, there are in fact 10. So, okay, I think I see what the solution would look like. But can I have that solution in here as a question, because that solution gives you a full grid of space, but I'm not sure if this solution would. It starts off with a night line indeed, however the night line is downward facing. So a plausible way to start off would look like this. Next is a horizontal line from the second point. So something like this. And then continue from there. Yeah, this actually doesn't really work out. You need a lot more space. Right? Wait, no. I see, there has to be... Right, so okay. This solution doesn't work. And it wouldn't work because it's on a grid that's rotated. Unless I shifted everything down. If I shifted everything down, there would be space. But I'm not sure there'll be space vertically. In fact, there isn't space here. Oh, so there just isn't space at all, per se. I don't think I can like flip the solution in any way. So that solution that I found wasn't just the only solution. And neither are all the reflections or rotations. Unless it is, and I just cannot figure out how to get this to work. Because this is rotationally symmetrical, right? So however I rotated my solution wouldn't work. Maybe reflection could work out. And so I could try a reflection. So a reflection could look like this. That's one line. Okay, then there exists a vertical line from the third of the horizontal. Well, there must exist a horizontal solution first, so... Yeah, this doesn't work because this is too far away. Like, the horizontal sort of looks like this, but it's slightly off. This piece over here and this piece should theoretically have formed a knight's move, but they don't because this one needs to be slightly further away. And now that it isn't slightly further away, it does not work out. If I try to do it like this, it is essentially just a 180-degree rotation of a puzzle, of a solution that I have already proved to be impossible. So that doesn't work. So that does mean there is more than one solution. Because this is an identical puzzle with some spaces removed. So how in the world am I supposed to be able to find a solution like that? I don't know. Okay, well, I guess most of it just find from other solutions. But let's try something like this and see where that brings us. We can try the same thing with the horizontal thing. I don't know why I said it like that. But actually, I can form another line. I can actually form another night line like this now. I look at it. Like that. That's the exact line I was looking for. So that makes 3. And in fact, that makes 3. Is there one that can give you 2 more lines? The 3 lines are this line, and this line. There exists one more line that can exist here. But can a spot complete another one? No. No, there must exist some diagonal, I think. But I don't see any diagonal. There was in fact a diagonal in the solution for 10, so there should be one here as well. I could also try to draw up a sort of solution. So in the solution that I had, the one that doesn't work, the topography, or the way that the lines crossed, I can sort of draw them out. And I can sort of like use that to figure out if I can find some way to connect everything. So, okay. I see the sort of diagram that this forms. This old solution, I don't know if I should just put it on screen right now. I think I might as well, just because oh. Yeah, okay. Oh shit. Alright, so here you see the old one. I can change the image, which I am going to. I am going to change the image to the one I took just now. Should be labeled, I think. Oops. Okay. Give me just a second here to find it. Find the old solution. Oh, this is a long time ago. Okay. So I'm getting close. There it is. Ooh, that's very zoomed in. Okay, so the old solution, apologies for the timeline at the bottom, it just had to be there for some reason. The old solution looked like that. And if I drew a diagram that sort of lined this up, I can see the number of intersections that I made are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are exactly 10 intersections here. So the answer is it's possible for 10 intersections to exist. The answer is, how else could I make 10 intersections exist like this that fits within this space? If I counted the number of rows, 2, 4, 6, 8, 2, 4, 6, 8. An 8x8 grid was required for this solution. In the original puzzle, we have a 2, 4, 6. We do have an 8x8 grid as well, except the corners are missing. Here, a corner is always required. And the reason why is because of the very last piece at the bottom. The last piece at the bottom sort of pushes the top to be at the corner, no matter what. However you rotate or rearrange it, it just has to take a corner piece. So I'm not sure how I might solve this. Is there any other way this could work? And I'm thinking it's plausible for a solution to exist where a piece is the intersection of three lines. So suppose it were an intersection of a vertical line and two diagonal lines, right? An intersection there requires a total of... The problem is it requires a total of 9 other pieces to form 3 total lines, right? Which would use all 10. And those 9 pieces are very unlikely to form any sort of other line themselves. I think it's possible to form almost lines with them if you use night lines, but I don't think you can actually form more lines with them. So let's suppose that that's not true then. Let's suppose that instead one of the lines is horizontal and one of the lines is just a regular night line. How can we make more intersections here? There is one intersection that already exists, but this uses a total of 7 pieces, right? Because 1 for the intersection point and 3 other lines here. If I wanted 10 intersections, I should have kept a sort of drawing of the previous diagram, which I probably will. It looks like the ideal solution utilized the intersection between... Well, it did use the intersection between a horizontal and a night line. Right. And in fact, that horizontal line eventually merged with a vertical line, so okay, so now let's then assume that our new solution has this horizontal and vertical in the center. And actually, what happened is that in the solution... actually, I might show up the solution right now. In the solution over here, the horizontal and night line that I said are actually in the center already. They're just rotated to form a vertical and a night line instead. But the difference I'll make is, let's say we have a vertical line in the center that crosses the night line and the horizontal line. That uses another 2 pieces. And we know that because the night line and horizontal line can only really provide 1. So we need to use 1 piece to form 2 more lines. And I'm wondering how that's plausible. I can make the new vertical line, the new cross, be more centered. So if I try to set that up in the actual puzzle itself, can I do that? So let's say I set up a horizontal line, followed by a night line here. I can form a vertical line that sort of cuts to the middle like this. But in what world does this ever form, you know, something that looks any nicer? I'm not sure. What if I used this instead? Do I get 3 of anything? Do these ever, you know, make any connection? Like, yes, the answer is yes. If I push this here, you form a diagonal that looks like that. Isn't this pretty similar to our old solution already? Like, I feel like it would be. So we could have another line that goes like this, almost forming a star shape actually. But where can that 4th line be? Somewhere along this diagonal, does there exist a 4th line? And I don't know if the answer is yes or not. Like, I can put one here, that forms another line. Same for this. But I don't think there's any other place where another line can be formed. Same for this, but yeah, no, none of those form an extra line. And I don't believe I can shift anything up. Okay. So again, let's eliminate everything here. I'm assuming this is a good start, but I'm not sure how. Another thing that I could have thought about was using lines that are not just night lines. So using things like 2x4 as my diagonal, but those are too big to fit anything. Same for 1x4s. 2x3s are like the best you can do, and 2x3s are night moves. Okay, let's move these out of the way. I do see a diagonal looking like this. So there could exist a diagonal that fits here. But suppose there were a diagonal that fits here. How can I resolve that? How can I form, more? There isn't really any 3s that I can form after this. And if I shifted this away, it's basically the same issue. Although actually now you can actually form a knight's move instead, theoretically. Here as well, you can form a knight's move-ish thing here. But all of these look so similar, I can't believe that any of them are even the, a valid way to solve the puzzle. They're way too similar. There is something here, there's a knight's move here that isn't necessarily required. There's also a vertical here which makes some sense. So a 4th line can be made like this, but no 5th line. This line is also shiftable. But the thing that is not shiftable is the knight line. So perhaps the knight line has to be where we start. Okay, the solution, the original solution, had the intersection of 2 knight lines somewhere. And the answer is yes, it did, but at one of the knight lines ended. So I'm not sure. Here we also have the intersection of knight lines in an X cross. And those are strictly forced. Those knight lines cannot change. Unfortunately, those knight lines cannot change. So let's suppose that those knight lines existed for now. There also exists currently a horizontal line passing through them both. And potentially a 4th vertical line down here. Is this similar to what the solution was? The solution involved a diagonal as well. So a knight line, a diagonal exists to cut through them both. Can I form one here? And how can I form one here? So taking out the pieces that are not necessary, let's just focus on these 2 knight lines first. Where? Where in the world could I have found a valid line? What? How in the world did I do that? Okay, I see. Maybe it's not possible in this arrangement. But I do notice that because there are knight lines which change parity per move, if the knight line existed somewhere else instead, so if it were, for example, something that were using this knight line as opposed to the other one, then a diagonal could exist somewhere. No, it can't exist somewhere. Does this just not let diagonals exist? Does this setup somehow not let diagonals exist? That would be very unfortunate if no diagonals could exist from this. But maybe the answer really is that no diagonals can exist from this. If I shifted it slightly instead, then yes, a diagonal could in fact exist if you had them not clash in the center. But I think clashing... See, the problem is that for them to not clash in the center, you will already use a full 8x8. Like, you would already have to use a corner, which doesn't exist here. So it almost feels like that isn't the thing here. Can I shift everything up? I can. What about here? That's an night line. You know what? It forms like a bunch of diagonals actually. This actually forms a ton of diagonals. Every single one of these are diagonals. So interesting. I never thought about that. We've talked about two centers of night lines colliding, the center and the end colliding, but we haven't yet figured out what happens if two ends of night lines collide. Every single other point, every other diagonal does work. And so, I guess that's one way to give us more options. Can we try a random diagonal and see what fits? I can do diagonals that form threes with horizontal and verticals, right? So there's one. Actually, it doesn't form threes, which is unfortunate. Can I form another night line here? Is that possible? I don't think it is. I just don't think it's somehow possible for another night line here. A night line colliding with two night lines already to form three total night lines just doesn't seem plausible. No. No, it's not. Okay, hold on. This is a valid 3. But there are no other valid 3s, is the problem. That's a valid 4. And by valid 3 I meant actually a valid line of 3. Not a valid set of 3 lines. But there is no solve here. Right? There's another 3 over there, but we have run out of pieces. So no, the answer is no. Okay. So... okay, question. What if I did somehow... Whoa, okay, that's just another night line. What if I somehow did another diagonal like this? That's a third diagonal. Starting from here. Could that somehow form a bunch of 4s? Somehow? I don't think it could. So this is the most random predicament. No, this doesn't fit. This gets somewhat close, but not quite. Like, okay, see, if I took this now, if I place one here, you actually form a lot of 3s. And by a lot of 3s, I mean actually a lot of 3s. You could form one here. You could form one up there. It also forms a possibility for a diagonal. But never enough to make 5, I think. Unless I try really hard. The thing is though, these spots are variable. So I can fit one in here, I can fit one up there. I don't know if this somehow forms like a multiple lines, but it seems like it doesn't. You know what? This would work in a certain case. And that certain case is if this was here and if this was somewhere off the board. If this was there, this would work. And I realize that now because this, I think, is simply just a rotation of the solution I created. If I could shift this over by 1 right there, this would solve the puzzle. Shift it over by 1, you form a diagonal like this. You form this line, this line, this line, this line, and a diagonal here. But that's not the solution I made, was it? No. Wait. No, it's not. It's not the solution I made. It's a different solution, but one that takes an equal amount of space. Because I will need to shift this over to the corner. We'll be basically using a corner and here. It takes an equal amount of space. And any amount of rotation will not solve this problem. Shifting everything down also won't solve this problem. This almost gets it, but not close enough. This is another solution, but... Okay, so this tells me that there are multiple solutions that work here. It's just, how in the world can I find one that fits in such a small space? One that doesn't use any corner at all. I don't know. I still think that the first thing to try is a nightline. Okay, but a lot of nightlines don't seem to actually work here. Hold on. That's a nightline. This is a nightline that doesn't really go very well. I form another nightline like so. And then form a diagonal like that. This is almost a star actually. In fact, it's so much so of a star that a star has 5 lines. You know what would be needed to complete this star? A horizontal line here and a vertical line here. That would complete this star. But unfortunately, I don't think I can do that. If I shift everything over there, that's almost kind of a star-ish as well. Unfortunately, the closest I got was actually this one here, because there is no other horizontal and vertical line that are in the same row and column. These are all slightly off by a little bit. But this one's fine. See these two? Which is why I thought that might have worked, but it doesn't seem to want to work. Oops, wrong button. Okay. So how shall I resolve this problem? Same thing with a diagonal. I mean, a diagonal and a nightline is what we started with from the beginning of the solve, I think. I think maybe the reason why I can't find solutions here is generally because a lot of the time night lines are hard to find. They're just really tough to spot. I can find a night line somewhere. Actually, that night line doesn't really work out because that night line ends in an empty spot where you can't place anything. Maybe shifting everything down by 1 is okay. Oh, but now this top thing doesn't have a empty spot anymore, and neither can that. So that night line can't exist. Any other nightline that exists somehow? Not really. Okay, this has to form the first two intersections already. Has to form quite a few things. It has to form possible nightlines, possible diagonals, possible horizontal and verticals. And if it can't do that, then it almost just does not work out. So a horizontal and vertical should be the best way to give us the most possibilities. Well, the only issue is that because there are so many possible horizontal and vertical lines you can make, same for diagonals actually, it's just really hard to find a solution that works. In fact, I want to see what my old solution looked like once I draw a diagram again. Was it also a star of some sort? Was it also a star of some sort? It almost looks like some kind of star. And a star indeed has 10 intersections. 1, 2, 3, 4, 5, 6, 7. Actually, every single point is an intersection of a star. The same is true for the diagram I made, though. Everything is an intersection as well. So I did make some kind of mangled star. But I don't think I can make a nice looking star here. Although, to be fair, a nice looking star would fit in the space because a nice looking star doesn't have any real corners. The problem is, how can I create that sort of shape? See, this doesn't even work. Not that thing. Oh, no, it does. What? Okay. Okay, the problem is that at this point, I think we have made too many night lines. I'm gonna make some diagonal lines that fit here. Diagonal lines like maybe like this. That's a diagonal line. That's 4, I guess, which is really interesting. In fact, removing this, you get like an A shape here, which isn't entirely. Oh, it's in the middle. There it is. Like, this is so close, and the reason why this worked was because there was a diagonal line here. So why didn't we have another one over there that fit? And I then realized you could just place one in the middle that intersects everything. So that's a solution. Whoa, how totally unexpected. Actually, and this is not like a star at all. How this works is it actually forms almost a triangle. It actually forms an A shape. And this A shape continues to form 2 more diagonals. So one like that, and one like hold on. Oh, it's yeah, it's the 2 diagonals. Also, the 2 diagonals don't meet. So still, everything is part of exactly one intersection. There is no 3-way intersection here, which is really interesting. So wow, that is a solution, alright. Okay, I gotta remember this in case I ever need to think about how this works again. But alright, what an interesting solve process. It's almost a derivation from the previous one. Okay, that puzzle took me like 40 minutes, but alright. Oh, it's the same thing. It's all the same thing, isn't it? Just find different solutions. Oh gosh. Alright, and you can't form... Okay, the original solution obviously doesn't work because no corner can form a knight's move anywhere else. I suppose the A thing doesn't work either. For some unknown reason. Okay, well it doesn't work because you can't form the middle A like this. Okay. Okay. What if I form the triangle? Is that useful? No, there's no like 3. Can I make almost solutions work? I don't think so. Like, this is almost the same thing. Except there's one small issue, so we just don't have another line we can make. Yeah, that's 4. So this is just another one of those, huh? I did make another solution before, right? Where it's the end of 2 knight moves. So let's see if we can try that here. 2 knight moves that collide at the ends. There exists a solution where this happens. I think. It just requires a corner. But this doesn't require a corner, does it? Does this even work? I don't remember having a solution here that works. Yeah, no diagonal here works actually, so... Let's see, I don't think I can shift anything. No, I don't think I can. What about a long diagonal? There's a pretty long diagonal here. A knight's move here. Well, would a knight's move here work? You can do this, so this is a decent start, I suppose. The only issue is that obviously this one and this one are knight's move apart, but there is no space down there because I didn't start up here. So obviously I can't do that. I can't do that same thing. How else can I do this? Is it really going to be just like 5 puzzles of this? I think it might be, which terrifies me. Okay, let's try a typical triangle. We haven't tried a typical triangle yet. Typical triangle is basically formed like this, followed by something like this. This does use 10, but I'm not sure. No, it uses 9. But I'm not sure if, you know, this is a satisfactory line that I can make. This forms a lot of 2s, but not enough 3s. Like this. Yeah. Lots of 2s, not enough 3s. You definitely have to use a knight move somehow to get through. But how would I get knight moves to work? Can I try the 2 knight moves touching at the tips again? Can this actually work is my question, and I am not sure if the answer is yes. The center is missing, which makes it very tough to do anything about. Like, there's just no space in the center. You can't make a mangled mess in the center if there's no space in the center. So this has to be like a clean, like, huge round, basically. Almost like a ring. So the question is, can I make a ring work? And I think I have to note is that everything has to be part of a okay, if I shift everything down by 1, which I can actually, I can form a diagonal. So that is a diagonal that fits. Question is, this thing is not part of anything. So, okay, so there exists this and this. Can I form some sort of loop? What is this an intersection of? Maybe a vertical line? Okay, vertical lines, parallel lines are not good. And I think parallel lines are not good because I know that parallel lines will always take up 8 spires. They cannot intersect, which is really unfortunate. And then afterwards, each spire needs to be part of a new line. And the thing is that for every point along a single line, that spire has to be part of a new line, which will make a total of 4 new lines that are not the parallel lines, which already forms 6 lines. And obviously, since the puzzle is asking us for 5, we can't actually form 6 lines. It's either impossible or, you know, or simply or simply not necessary, requiring a much greater setup. So parallel lines are not good. Parallel lines are not good. However, the idea of everything being part of an intersection makes it more interesting to me. This night line over here, every point along this night line must be part of another line, which is something I never talked about before, but I am now realizing that every point along this night line must be part of a new line. So now I can ask some questions about the puzzle. For example, what kind of line is this part of? And suppose I say the answer is a vertical line. With 2 lines now, every single thing must be part of another intersection. So 3 lines, for the remaining 3 intersections each, you will then have 3 lines that cross at 3 points. So those 3 lines form a triangle. Is that true? Well, not only do they form a triangle, they must form some sort of special thing here. So for example, I can form this, that works. That's a really interesting. Actually no, it's just 2 night lines, okay. There's 2 night lines doing that. No, this isn't it. Okay, I think if I pushed everything up, I have another line I can make. Here? Oh. Ugh, I don't know if I like that. Yeah, I don't know if I like that. This goes away. What is this part of? I don't know. Okay. But now let's think about what these 2 be part of lines. What these 2 will be part of. There could be a line crossing these 2. So you can form another one here. This one, what would this be part of then? Maybe this could somehow be part of... this? Perhaps starting with that is not right. Let's say I start with the horizontal line instead. Every single part of this horizontal line must be part of a new line. Okay. Next, let's say I then switch to something like a vertical line. Vertical lines actually didn't exist in the previous solution, which is interesting. Because I'm like staring back at it to see if I can make any kind of revelation. What line would this be part of? This could be a line that intersects this. So it could either be a night line, which I could try. Okay. So now we have 3 lines. What line would this be part of? Well, almost forms a diagonal with this. But now I'm missing one, right? Yeah, I'm missing one. This one can't do anything about it. Okay, so I'm gonna remove this guy. I can place you in here. It's a more snug spot. But ultimately probably does not really help. The thing is, this so-called snug spot actually allows for this to form a knight's move away, which is nice. But that knight's move only exists for one other piece, so. Also doesn't. Okay, hold on. Here. So yeah. In fact, this doesn't actually like do anything special. But I suppose this is an interesting start. Interesting start to a solution I have to come up with eventually. Okay, well, I think this doesn't really fit anymore. This line is not part of anything. So is this, I think. Is there anything else? Yeah, this isn't part of anything either. Part of 2 lines, basically, is what I'm saying. Everything else should be part of 2 lines in some way. But those 3 are not, which is very distressing. Okay, well, I don't think I can really find a solution this quick. I think I'm just gonna leave it off here and say we probably tried our best, haha. Yeah, we'll try continuing this next episode when we maybe have more of an insight. Until then though, I think I'm gonna be off for now. So yeah, hope you enjoyed the video. I'll see you guys next time. Bye bye.